It's a hot day in the southern reaches of the world, and you're swimming off the coast of Australia, enjoying the crystal clear water, when suddenly you brush against something that feels like silk ribbons. You take a second and marvel in the luxurious feeling of this underwater silk wrapping around you. But then you suddenly panic as you realize where you are, and the fact that you're now getting touched by some mysterious thing in the water. And so as you look down, you see what appears to be a floating transparent jellyfish, only a few centimeters or inches in diameter, with long, dangling tentacles. And upon realizing this, you suddenly feel excruciating pain where it's touched you. Which all I have to say to that is, congrats. You just met the Australian box jellyfish, Chironix fleckeri, and have been in turn severely envenomated by it. Which now means, by the way, that you have approximately 5 minutes to live. And yes, you heard that right, 5 minutes. Less time than it takes to microwave a frozen burrito. But here's the thing that'll really mess with your head if there's an afterlife, which is that this jellyfish isn't some rare exotic nightmare fuel. It's just one member of a club that includes 15% of all animal species on Earth. Let that sink in. We're talking about 1 in every 7 animals packing some form of venom, which with those numbers is basically nature saying, you know what would be fun? Death in the most excruciating of ways. And this 15% is not just snakes and spiders here. We're talking about mammals with venomous elbows, snails that fire little harpoons loaded with insulin to give fish food comas, and creatures with venom so potent that it causes literal feelings of impending doom. Because yeah, it is. But before we dive into this chemical hellscape, let's get one thing straight. There's venom and there's poison. And no, they're not the same thing. Here's the deal. If it bites you and you die, that's venomous. If you bite it and die, that's poisonous. You see, venom has to be actively injected, through fangs, stingers, spines, or in the case of the slow loris, through mixing their elbow gland secretion with spit and delivering it via tooth comb. And no, I'm not making that up. And so the technical definition of venom is any harmful chemical secretion that an animal actively introduces into another animal through a wound. Meanwhile, poison just has to be absorbed, so no active injection required. Take the golden dart frog, Phyllobates terribilis. This little yellow guy, who looks like a rejected Pokemon design, is often thought of as one of the most venomous animals on Earth. But in reality, it's one of the most poisonous animals on Earth. Its poison is excreted by its skin, and the Embera people of Colombia have utilized this poison to create in some ways an artificial venom, coating their blow darts with its secretion. And get this, one frog can coat anywhere from 30 to 50 darts depending on how you extract it, which lasts for up to 2 years before needing to reapply, with each dart being poisonous enough to kill a full-grown human, with the alkaloids in its skin being hundreds of times stronger than morphine. But here's where it gets weird. If you raise that same frog in captivity and fed it to regular fruit flies instead of the specific ants and mites it eats in the wild, it becomes completely harmless, as these guys basically stockpile the compounds found in others, as opposed to producing them endogenously. But unfortunately, I do have to mention that this is not the same for venomous animals, as they're pretty much always at some level of no thank you, regardless of what it's eating. And this has obviously worked pretty well, considering that again, 15% of Earth's animals end up packing biological chemical weapons. And interestingly enough, it's often thought that many early mammals were also venomous, which is also why the platypus is, having retained that trait from a distant ancestor, but we'll get to that later. Now, why we have venom in general is a different story. Imagine you're a prehistoric fish, just swimming around minding your own business 400 million years ago, and then some other fish tries to prey on you with its newly evolved teeth. In response to this, you evolve armor, and they evolve stronger jaws, so you evolve thicker armor. And this goes on for millions and millions of years, until eventually someone just says, screw it, and evolves the ability to inject toxins directly into their enemy's bloodstream, bypassing all that need for those strong physical capabilities. And that's basically what happened, except multiplied by every animal on Earth trying to either eat or avoid being eaten. So basically it's an arms race that has been going on for hundreds of millions of years. And while we don't know for sure when the first venomous animal evolved, it's definitely been a while considering certain evolutionary relationships, such as the emergence of cnidarians, an entirely venomous group that goes back at least 600 million years ago. So yeah, it's been around for a while. And with an arms race going on for that long, especially one that's so widespread, with venom usage having evolved independently at least 104 times, let me tell you, the arms have gotten absolutely insane. Every time a prey animal evolves resistance to a toxin, the predator has to cook up something new, and vice versa. And when I say cook up, I mean that literally, as venom glands, the things that produce venom in many different animal lineages, are basically mobile chemistry labs that would make Walter White weep. And a single venom gland can produce hundreds of different proteins and peptides, each one designed to ruin your day in a very specific way. And so now you might be thinking, proteins, isn't that the stuff we eat to bulk up? And the answer to that is, well, yes and no. The chicken breast on your plate has protein, obviously, but it's basically inert, just serving as building blocks for your body to recruit to power it. However, venom proteins and peptides, on the other hand, are highly specialized, being folded into shapes that can lock onto your nerve channels, clot your blood, punch holes in your cells, etc. So while one helps build your body up, the other shuts it down. And perhaps the most famous example of venomous animals are snakes, and for good reason too. As out of the roughly 4,000 different species of snakes, nearly 15% of them are venomous, with about half of that number being considered medically significant, which is a nice way of saying you do not want to be bitten by one of these guys. And most of these medically significant snakes are elapids, i.e. cobras, mambas, and coral snakes, or vipers, while the rest are then a mix of other families that evolution for some reason decided also needed some deadly kill-you juice. Now broadly, their venoms are dominated by 4 different protein families, with names that kind of sound like Latin death metal bands: phospholipases A2, metalloproteases, serine proteases, and then 3 finger toxins. And each family of snake brings its own special brand of horde to the party. Elapids tend to load up on 3 finger toxins and phospholipases, aiming mainly for your nervous system, while vipers prefer metalloproteases, serine proteases, and phospholipases, wanting to mainly liquefy you from the inside. Now, if I was to name every specific sort of family, compound, etc. that contributes to the different venoms of the world, this video would be exceptionally long. But luckily, or perhaps unluckily, after millions of years of this evolutionary arms race, most venoms have settled into 4 basic flavors of you're screwed, which I like to call the 4 horsemen of the Venom-pocalypse, which sounded better in my head, if I'm being honest. Now, perhaps the one that most people know by name are neurotoxins. And unsurprisingly given their name, they are toxins for your nervous system, messing with essentially the power lines in your body, generally with the end result of them no longer working. Except instead of turning you off immediately, you're generally still conscious to enjoy the whole experience. But to understand why they're so terrifying, you need to know how your nerves actually work. And honestly, it's pretty simple. Every time you want to move, an electrical signal races down your motor neurons at about 120 meters per second. When it reaches the end, calcium channels open, releasing little packets of a chemical called acetylcholine. This acetylcholine floats across a tiny gap and binds to receptors on your muscle, thus telling it to contract. And what neurotoxins do is break the system in absolutely diabolical ways. For example, the black mamba, which fun fact can slither at 12 miles per hour, so faster than most people jog, has venom made up of primarily of something called dendrotoxins and alpha neurotoxins, with the latter being a 3-finger toxin and the former being a type of protease inhibitor. And the most toxic part is the alpha neurotoxins, as these guys latch onto your nicotinic acetylcholine receptors like biological superglue. And so, the end result is your brain screaming commands and thus pumping acetylcholine to power your nerves, but the receptors are blocked, and thus your muscles do not work. And now, being unable to move is terrifying enough, but you also have to realize that there's a very important muscle in your body that keeps you alive. And you might be thinking your heart, which is very true, but there's also another one, your diaphragm, that lovely thing that helps you breathe. But after getting bitten by Kobe Bryant's namesake, or should I say named snake, you have maybe 1 hour before your diaphragm just stops, which let's just say also spells your doom. And the best part is you're awake for all of it. But snakes aren't the only ones playing this game, as meet the irukandji jellyfish, which is basically the Australian box jellyfish's psychotic little cousin, being related but of a different family. And when I say little, I mean that literally, as this thing is the size of your fingernail, if that, which makes them all the more terrifying as there is no way you'll see it coming. And yet, its sting filled with neurotoxins caused the horrifying condition called irukandji syndrome. At first, nothing happens. Well, for about 30 minutes or so, as around that time, boom. Suddenly your muscles cramp so severe that you can't straighten your limbs, you start vomiting which won't stop, sweating like you're in a sauna, blood pressure hitting 300 over 180, and oh yeah, can't forget the last one, a sense of impending doom, which is actually the medically relevant term for it too. And it is so bad that some victims have literally begged their doctors to kill them because the experience is so painful and terrifying. But don't you worry, if you survive, you only need to potentially endure this for up to 2 weeks. So bad. With one victim saying, and I quote, "I didn't think it was possible for anyone to endure that level of pain without turning into a vegetable." So moral of the story, the typical, Australia is terrifying. But my favorite, and by favorite I mean scariest, has to be the cone snail. Yeah, you heard that right. A snail. Except this is a snail with a gun, as these things have evolved a biological harpoon, specifically a modified radula tooth that can shoot out like a bullet. And this venom is loaded with proteins rightfully named conotoxins, which are neurotoxins, of course. But as the cone snail is really actually a family of snails, don't be mistaken in thinking they're all the same, or that they all have the same venom, as depending on the specific species, multiple different types are available to make sure that whatever it hits is done for good. For example, the delta and mu conotoxins block sodium channels, the omega conotoxins block calcium channels, the alpha conotoxins block nicotinic receptors, and kappa conotoxins mess with potassium channels. But either way, the end result is no thank you. And symptoms can start immediately after a sting, or only start days after, with severe cases involving paralysis, respiratory failure, and sometimes death. There's even one species of cone snail so lovingly named the cigarette snail, and not because it has nicotinic receptor blockers, but rather because that's how long you now have to live. One cigarette smoke's worth. Oh, and fun fact. One other species of cone snail also evolved a special type of insulin that they inject instead, causing rapid hypoglycemic shock in fish. So yeah, all this said, neurotoxins are some pretty scary stuff. But that's just one out of the 4 general types. And if we can summarize neurotoxins as being about messing with the power lines, so to speak, then we can say that hemotoxins are about destroying the plumbing. And boy oh boy, do they commit to the bit. Now, your blood is unsurprisingly an incredibly complex system. You've got about 5.5 liters of it, or 1.5 gallons, which contains red blood cells, white blood cells, platelets, and hundreds of other proteins that all work together. I mean, the clotting cascade alone, the thing that creates scabs among many other things, involve 13 different factors that work together in an intricate system. And so what hemotoxins have done is look at this beautiful, complex system and say, what if we broke literally all of it? The Russell's viper, responsible for thousands of deaths across Asia every year, has venom that does precisely this. It contains factor 5 and factor 10 activators, i.e. things that trigger specific steps in your clotting cascade. And activating your clotting factors out of nowhere is, let's just say, not good. And the problem is that the Russell viper venom does not just activate these factors where it bites you, but everywhere, all at once. So suddenly your body starts forming thousands upon thousands of tiny clots throughout your circulatory system, which in turn use up all your clotting factors and platelets in what doctors call consumptive coagulopathy. And once these are all used up, you now can't clot anymore. And that might not sound that bad, but just for the record, you don't only rely on clotting when you actually have a big wound. In fact, you probably have millions of micro wounds at any given time. And now that your body has no ability to form clots, you suddenly start bleeding from everything. Gums, nose, eyes, internally, etc. And yes, there are cases of people literally bleeding from their eyes. And here's the really messed up part. Hemotoxic bites often look fine at first. You get bit, might see a little bit of swelling and think, I'll walk it off. But meanwhile, the venom is making rapid work of your circulatory system. And shortly after, you're peeing red, and your kidneys are failing because they're clogged with cellular debris. Surprise! And it's not just snakes who do this. In fact, even we mammals do, with vampire bats also producing a type of quote-unquote hemotoxic venom, specifically having anticoagulants in their saliva called draculin, which is, yes, named after Dracula, as well as something else called desmotoplase. And these two things keep blood flowing while they're feeding, effectively interrupting the clotting process. And they're so effective that bite wounds bleed freely even after the bat stops feeding. And so with all this said, hemotoxins are absolutely messed up. But it's time to move on to the real nightmare territory, cytotoxins. You see, cytotoxins don't mess around with your nervous system or your blood. Well, at least not by design. Instead, they just destroy whatever the heck they can get their hands on. In other words, they go straight for your cells and basically melt them. Most of the cells in your body are surrounded by membranes made of phospholipids, fatty molecules arranged in a double layer. You can kind of think of it like a soap bubble that keeps all your cellular goodness inside. And cytotoxins are designed to pop that bubble, with the end result being bad. And there is perhaps no better poster child for this horror show than the brown recluse spider. Now initially its bite might feel like nothing, maybe a little pinch, but its venom contains sphingomyelinase D, an enzyme that literally only exists in a few different insects and some bacteria and fungi. And what this little enzyme does is cleave the sphingomyelin in your cells into ceramide 1-phosphate and choline. So yes, long words you've likely never heard of before, but still very crucial. And why? Well, it is critical for membrane integrity. Without it, your cells essentially dissolve. And so within hours, you've got a spreading necrotic lesion that looks like someone took a spoon to a melon, except the melon is your flesh. In other words, the tissue just dies, and dies, and dies, with wounds often taking months to heal, leaving deep indented scarring. And this enzyme also does something very diabolical, which is that it indirectly triggers something called neutrophil chemotaxis, which basically means it attracts white blood cells to the area. But instead of helping, they release their own destructive enzymes, making everything just that much worse. and the end result is that some victims require skin grafts covering areas the size of dinner plates. And I've seen pictures, which I'm not going to show, but let me tell you, it's bad. And terrifyingly, spitting cobras have figured out how to weaponize this from a distance, being able to spray venom up to 10 feet or 3 meters away with scary accuracy. 90% accuracy, to be precise. Get it? Always aiming for the face and eyes. And why the eyes? Well, 1, because it needs to target a mucous membrane to be effective, and 2, because cytotoxins plus eyeballs equals blindness, with the venom literally dissolving your cornea layer by layer. And just to make these guys even scarier, they don't even need a spit. They can, and absolutely will, bite you as well, injecting the venom directly. And in a similar case of turning your cells into soup, the king brown snake had mastered this too. But instead of making cell soup, they decided to make muscle soup, as that's exactly what mitotoxic venom does, the type which they have. You see, your muscles are made of highly organized protein fibers that are all packed inside a cell that's surrounded by something known as the sarcolemma. Mitotoxins dissolve the sarcolemma, which if you couldn't guess, is not ideal. Within hours of a bite, something called rhabdomyolysis can occur, which you might have actually heard of before if you're into fitness, something which is colloquially called rhabdo. And this is basically when your muscle cells break down so fast that they overwhelm your body. Your pee turns the color of Coca-Cola because it's full of myoglobin, the protein that stores oxygen in muscle. And here's the problem. When this happens, the influx of myoglobin hits your kidneys, essentially clogging them like hair in a drain, causing the heme, i.e. iron, to release, driving oxidative stress in the kidney's tubules, meaning, hello kidney failure. But now you might be thinking, why kill something through kidney failure if you can just kill them by, stopping their heart? And that's a great question, one that animals with cardiotoxic venom were thinking as well. These toxins skip the foreplay and go straight for the throat. Well, chest. I mean, your heart is basically just a specialized muscle beating about 100,000 times per day. And so if it doesn't beat anymore, that's just not compatible with life. Remember the box jellyfish I mentioned earlier? The one that can kill you in 5 minutes? Its tentacles are lined with millions of ctenidocytes, which are basically microscopic harpoon guns. Each one contains a nematocyst, a pressurized capsule with a coiled barbed thread inside. And when triggered, these fire with an acceleration of 5 million Gs, which to put that into perspective, if it kept its acceleration for 1 second, then it would move 49 million meters or 116 million feet. In other words, 16% the speed of light. But of course, the speed is just the beginning, as when these harpoons punch through your skin, they inject a cocktail that includes proteins called porins that essentially create holes through your muscles and blood cells. And these holes then create channels that cause a massive amount of calcium to rush in. And if enough venom gets into circulation, the same damage can then hit the heart. And it acts so fast that victims can be found dead within just a few minutes of a sting. And some cobras also specialize in this, having 3-finger cardiotoxins that work more slowly, but just as surely. And now, theirs essentially make the heart's machinery work incorrectly, gradually making your heart beat weaker and weaker until it just stops. Kind of like a sad balloon slowly deflating, except the balloon is keeping you alive. Now at this point, you might be thinking, okay, snakes, spiders, jellyfish, I'll just avoid those. And to that I say, my sweet, sweet summer child, let me tell you about our little cousin, the platypus, who also happens to be the owner of algogenic venom. The platypus, which is honestly already an evolutionary fever dream, seeing that the females lay eggs, despite being a mammal, have spurs on their hind legs, which in the males are venomous. And that's great and all, but the terrifying part is that this venom is algogenic, which in case you don't speak Greek, algo means pain and genic means causing. So yeah, a venom so bad it's literally named pain-causing. And shocker, that's exactly what the platypus venom does, causes pain. Lots and lots of it. And you might be thinking, well, okay, it causes pain, but honestly that doesn't seem so bad. I mean, you're not gonna die from pain alone. I can just take a painkiller. And yes, that's generally true. But here's the kicker. It causes pain so intense that literal morphine does not help. Let me repeat that for those in the back. Morphine does not help. So while it might not literally kill you, it definitely can make you wish you were dead. And the way their venom works is by affecting the nerve cell's tolerance to pain, essentially lowering the threshold to cause pain signals. In other words, everything hurts more. Moving hurts, not moving hurts, existing hurts. And the worst part is that victims reported pain lasting for months. Terrible pain, with one researcher describing it immediate, sustained, and devastating. And even years later, the affected limb can have after effects, with one victim reporting pain in his hand even 15 years later. And here's what's really messed up. We don't have antivenom for it. Because honestly, who expects to need platypus antivenom? It's like preparing for a unicorn attack. But if researching different animals has taught me anything, it's that when you're in Australia, expect the unexpected. Because yes, they're from Australia. So here we are, venom. Bad stuff. But you might be thinking at this point, Wait a second, I thought you said there were 4 horsemen of the venom apocalypse, not 6. And yes, I did say that, but I would be lying if I said the first 4 are the only types, as the problem is that there's numerous ways that venom can target your body, all of which could get their own special name. But the key thing is that these other venom types, like cardiotoxic and algogenic for example, are generally specific subsets of the first 4, the real horsemen, those being cytotoxic, neurotoxic, hemotoxic, and myotoxic. For example, cardiotoxic is generally a subset of cytotoxic or myotoxic, while algogenic venom is generally an aftereffect of pretty much any other type. I mean, you better bet the cytotoxic venom would be absolutely excruciating. And another great example of this is nephrotoxic venom, meaning toxic to the kidneys, which can also be a focus for venom, but is often just a byproduct of another function of the venom. For example, myotoxic venom causing rhabdo, which in turn causes kidney failure. But all in all, do not play around with venom. And I'm not talking about the supervillain. But guess what? Your odds of running into our venomous friends is only set to increase. And why? Well, you might have noticed a recurring trend, which is that many, if not the vast majority of venomous animals, live in areas where the weather is warm. And guess what? With climate change and thus rising temperatures, venomous animals are moving to new areas. For example, models predict the West African gaboon viper, the snake with the largest fangs in the world, and also highly venomous, could more than triple its range by 2070. And other venomous snakes are even predicted to start moving to entirely new countries, where they haven't been found before. And every year, venomous snakes envenomate around 3 million people, resulting in around 150,000 deaths. And remember, these are just from snakes, and are just the ones we know about, with most bites happening in rural areas where people cannot get the treatment they need, with some studies suggesting that in certain areas, bites are underreported by a factor of 30. For example, in sub-Saharan Africa, most victims never even make it or go to a clinic. And the real tragedy is that anti-venom actually exists for most species, well, snake species, but it's expensive, requires refrigeration, and multiple vials just to treat one bite. But as nature taketh, so can it giveth, and the same venoms that kill can also heal. The Brazilian pit viper, like its cousin the Russell's viper who can make you bleed from your eyes, has venom containing bradykinin potentiating peptides, and scientists figured out how to isolate these, modified them, and created a drug called captopril, one of the most important blood pressure medications ever, being the very first ACE inhibitor, and so it alone has saved millions of lives. And the Gila monster, a cranky old lizard that's been known to kill its owners, well, its saliva contains Exendin 4, which in turn became exenatide, a diabetes drug that helps many control their blood sugar. Even the freaking assassin, known as the cone snail, has given us an incredibly important medication, ziconotide, also known as Prialt, a painkiller that is 1,000 times stronger than morphine, but without the addiction potential. So for people with chronic pain who can't take opioids, it can be life-changing. And that's just the tip of the iceberg. Many other medications have used things we've found or learned of through studying venom. And scientists are currently studying platypus venom for diabetes, spider venom for insecticides that only affect insects, snake venoms for anti-cancer compounds, and scorpion venoms for immunosuppressants, just to name a few. So while for peace of mind, it might seem like a great idea to just wipe out all venomous animals, in reality, they have likely saved, or will save, far more people than they ever have killed. Thanks for watching, and until next time.